When most people think of legendary Japanese engines from the Golden Era, names like the RB26, 2JZ, and SR20 immediately come to mind. But there's one engine that often gets overlooked despite having the pedigree to stand toe-to-toe with any of them. An engine that dominated American road racing, set land speed records, and powered one of the most technologically advanced sports cars of the 1990s. This is the story of Nissan's VG30, specifically the naturally aspirated VG30DE and the twin-turbocharged VG30DETT, two variants of the same engine that proved Japanese engineering could create something both sophisticated and brutally effective. Before we dive into the stars of our show, we need to understand where they came from. In 1983, Nissan unveiled the VG engine family, Japan's first mass-produced V6 engines. This was significant because for decades, Nissan had relied on their legendary inline-six engines, like those found in the original Skyline GTR and the 240Z. But times were changing. The industry needed engines that were more compact, more fuel-efficient, yet still powerful enough to compete in an increasingly competitive market. The VG designation stood for something greater than just another engine code. Nissan added it to their Plasma engine family, which stood for powerful and economic, lightweight, accurate, silent, mighty, and advanced. It was an ambitious mission statement, and one that Nissan was determined to fulfill. These engines featured a 60-degree V6 configuration, chosen specifically for its balance of compactness and smooth operation. Early VG engines used a cast-iron block with aluminum heads, a proven combination that prioritized strength and durability over outright weight savings. The first iterations were single overhead cam designs with 2 valves per cylinder, solid performers but nothing revolutionary. It was clear from the beginning, however, that Nissan had bigger plans for this platform. The VG30DE made its debut in 1985 at the Frankfurt Auto Show, showcased in the striking Nissan MID4 concept car. This wasn't just another engine variant. This was Nissan's statement of intent. The VG30DE featured dual overhead camshafts and 4 valves per cylinder, bringing the total to 24 valves across the V6. This was cutting-edge technology for a Japanese manufacturer at the time, showing that Nissan was serious about performance. The engine displaced 2,960 cubic centimeters with a bore of 87 millimeters and a stroke of 83 millimeters. This over-square design meant the bore was wider than the stroke, a configuration that favors high RPM performance and allows the engine to rev more freely. Compression ratios varied between 9.0 to 1 and 11.0 to 1, depending on the application, striking a balance between power and efficiency. But what truly set the VG30DE apart was its advanced valve timing system. Nissan equipped it with NVCT, Nissan Variable Cam Timing, an early form of variable valve timing that adjusted the intake cam timing to optimize performance across the RPM range. At low engine speeds, the system reduced valve overlap to provide a smooth, stable idle and strong low-end torque. As engine speed increased, the system advanced the cam timing to improve breathing and top-end power. This was sophisticated engineering that gave the VG30DE the best of both worlds. 2 versions of the VG30DE existed. The first generation, introduced in 1986, was exclusive to the Japanese market, appearing in models like the 300ZR and the Nissan Leopard. It produced around 190 horsepower. The second generation, launched in 1989, was the first to reach North American shores in the Z32 300ZX. This version received further refinements and produced 222 horsepower at 6,400 RPM and 198 pound-feet of torque at 4,800 RPM. For a naturally aspirated 3.0-liter V6 in 1989, those were impressive numbers that could compete with far larger American V8s of the era. The VG30DE proved its capabilities beyond the street. Production blocks and cylinder head castings were successfully used in Nissan's GTP ZX Turbo and NPT 90 race cars, which won the IMSA GT Championship 3 years in a row between 1989 and 1991. That a production-based engine could compete and dominate at such a high level of motorsport spoke volumes about the fundamental strength of its design. While the VG30DE was impressive, Nissan knew they could extract even more from the platform. In 1987, Nissan unveiled the VG30DE-TT in the MID4-2 concept car, a mid-engine supercar that was meant to challenge Ferrari and Porsche. The concept car's engine produced an astonishing 330 horsepower, but when the VG30DE-TT reached production in the 1989 Fairlady Z for the Japanese market, it was rated at 280 PS due to the infamous gentleman's agreement among Japanese automakers. This agreement limited advertised power to 280 PS to avoid an arms race and keep sports cars eligible for GT300 class racing. In reality, independent testing showed the VG30DE-TT was producing closer to 302 horsepower from the factory. For the North American market, which wasn't bound by the gentleman's agreement, the 1990 300ZX twin-turbo officially made 300 horsepower at 6,400 RPM and 283 pound-feet of torque at 3,600 RPM. Those numbers might not sound earth-shattering today, but in 1990, this was supercar territory. The 300ZX could sprint from 0 to 60 in just 5 seconds flat, faster than the contemporary Ferrari 348 and on par with the Porsche 911 Turbo. But raw power numbers only tell part of the story. What made the VG30DE-TT special was how that power was achieved and how sophisticated the engineering was beneath the valve covers. The VG30DTTT retained the same bore and stroke as the VG30DE, 87 by 83 millimeters, but the compression ratio was lowered to 8.5 to 1 to accommodate forced induction. The iron block remained, providing the rigidity and strength needed to handle boost pressures. But Nissan made numerous internal upgrades compared to the naturally aspirated version. The pistons featured fully floating gudgeon pins, piston oil squirters to keep temperatures under control, and cooling channels. The connecting rods were made from micro-alloyed steel and featured upgraded bearing materials. The crankshaft was also micro-alloyed steel and was 10% stiffer than the VG30DE's crank. Even the exhaust manifolds were upgraded, cast from Nye-resist material that could handle temperatures up to 900 degrees Celsius, 3 times stronger than conventional cast iron at those temperatures. The cylinder heads were masterpieces of design. They featured a 45-degree pent-roof combustion chamber with 2 quench pads per chamber, positioning the spark plugs close to the bore center for optimal combustion. The ports were designed for maximum flow, with nearly a straight shot to the combustion chambers. And like the VG30DE, the VG30DTTT featured Nissan's NVTCS, Nissan Valve Timing Control System on the intake cams. This variable valve timing could add up to 30 pound-feet of torque below 6,100 RPM, while maintaining the smooth idle of a luxury car. The forced induction system was equally impressive. In an era when most manufacturers were using single turbochargers, Nissan chose a parallel twin turbocharger setup using custom-developed hybrid Garrett T25 by T2 turbochargers. Each turbo used a T25 compressor and a T2 turbine, reducing rotational inertia by 30% compared to a single large turbo of equivalent flow. This dramatically improved throttle response and reduced turbo lag. The turbos featured ceramic turbine wheels and standard trim, though N1 spec performance versions used steel turbines for increased durability under racing conditions. Twin intercoolers cooled the compressed air before it entered the engine, and the whole system was managed by Nissan's advanced engine management system that controlled fuel, spark, and boost electronically, cutting-edge technology for 1990. The VG30's competition history is nothing short of legendary, though it often gets overshadowed by the RB26's exploits in touring car racing. But make no mistake, the VG30 was a giant killer on American soil. In 1984, Nissan partnered with Electromotive Engineering in California to develop a GTP prototype racer for the IMSA GT Championship. The team started with Lola chassis in 1985, but by 1987, chief designer Trevor Harris had developed their own chassis to house the turbocharged VG30. The team assembled an all-star cast of engineers: Don Devendorf, who had worked at Hughes Aircraft on electronics; Wes Moss from Holman Moody, who had built the Le Mans-winning Ford GT40; and aerodynamicist Yoshi Suzuka, whose work with Nissan dated back to the BRE racing days. The GTP ZX Turbo made its first win at Miami in 1987, but 1988 was when everything clicked. Australian driver Jeff Brabham won 8 consecutive races that season, a streak that remains legendary in IMSA history. He claimed the Drivers' Championship, but Nissan missed the Manufacturers' title by just 1 point because the team had skipped the endurance races at Daytona and Sebring. Determined not to repeat that mistake, Nissan returned for 1989 with a vengeance. The team entered Daytona and Sebring despite reliability concerns. They won 10 races that season and finally dethroned Porsche, winning both the Drivers' Championship, again with Brabham, and the Manufacturers' Championship. It was the first time since 1983 that something other than a Porsche had won the IMSA GTP Constructors' crown. In 1990, Nissan Performance Technology Incorporated introduced the NPT90, an all-new design that was even more advanced. Though it continued to race under the GTP ZX Turbo name for marketing purposes, the NPT90 was a completely new car. The race-spec VG30 in these cars produced over 950 horsepower, thanks to extensive development by the team. The NPT90 won the championship in both 1990 and 1991, with Brabham securing his 3rd and 4th consecutive drivers' titles. The VG30's motorsport success extended beyond circuit racing. In 1991, a modified 300ZX set a land speed record in the E/BMS class at Bonneville, achieving 260.87 miles per hour. The engine had also found success in Trans Am racing and won the 1994 24 Hours of Daytona. This was an engine that could dominate in any form of motorsport it entered. On the street, the VG30 DETT quickly earned a reputation as a reliable powerhouse. With proper maintenance, naturally aspirated VG30 engines regularly exceeded 300,000 miles. The turbocharged VG30 DETT could easily surpass 200,000 miles when properly cared for. The engine's only real weakness was that it was an interference design, meaning timing belt maintenance was absolutely critical. A broken timing belt could cause catastrophic damage. Other common issues on aging examples included oil leaks from degraded gaskets, corroded electrical connectors, and clogged fuel injectors, all typical problems for engines of this era. The tuning community quickly discovered that the VG30 DETT was built like a tank. On stock internals, the engine could reliably produce 450 to 500 horsepower with upgraded turbos and tuning. The cast iron block, forged steel crankshaft and connecting rods, and oil-cooled pistons meant the foundation was incredibly strong. Popular upgrades included swapping to larger T28 or HKS GT2530 turbochargers, upgrading the intercoolers, installing a free-flowing exhaust, and tuning the engine management. For those chasing serious power, stroker kits were available that took displacement up to 3.1 or even 3.2 liters by overboring to 89 millimeters and adding stroke. With forged internals, aggressive camshafts, ported cylinder heads, and large single turbo conversions, the VG30 could produce over 800 horsepower. One notable build by Jorge Lizcano ran a 6.77-second quarter mile at 201 miles per hour, making it the first VG30 DETT to break into the 6-second range. Drag racing builds have pushed these engines beyond 1,350 horsepower, proving that the fundamental architecture was more than capable of handling extreme power levels. Z32 300ZX that housed the VG30 DETT was as impressive as the engine itself. Nissan used Cray 2 supercomputers to design the car, making it one of the first production vehicles shaped with advanced CAD modeling. The result was a sleek, muscular body with a drag coefficient of just 0.31, significantly better than the 0.40 of the R32 Skyline GTR. This aerodynamic advantage made the 300ZX exceptionally stable at high speeds. The twin-turbo models came equipped with super high-cast four-wheel steering, the same system used on the Skyline GTRs. This computer-controlled rear-wheel steering system dramatically improved handling and made the car feel planted through corners. The suspension used a sophisticated multi-link rear design shared across Nissan's Project 901 platform, which included the Z32, R32 Skyline, and other premium Nissan models. The engine bay, however, was notoriously cramped. With twin turbos, twin intercoolers, and all the associated plumbing packed into a relatively small space, routine maintenance could be challenging. Enthusiasts joked that if you could work on a 300ZX engine bay, you could work on anything. And there was truth to that statement. But the tight packaging was a necessary compromise to achieve the car's proportions and weight distribution. The Z32 received widespread critical acclaim. Car and Driver placed it on their 10 Best list for 7 consecutive years, every year it was sold in the United States. Motor Trend awarded it Import Car of the Year for 1990. The automotive press praised its performance, build quality, and advanced technology. American Z-Car sales reached 1 million units during the 1990 model year, making it the best-selling sports car at that time. While the 300ZX never achieved the same pop culture saturation as the Supra or Skyline GTR, it carved out its own niche in Japanese car culture. The Z32 twin-turbo became a favorite among the Wangan expressway racers in Tokyo during the early 1990s. Tuning shops like Revolve, Jun, Border Racing, and Valeside built highly modified 300ZXs capable of sustained 200-plus mile-per-hour runs on the Wangan. These cars featured massive turbo upgrades, reinforced cooling systems, and aerodynamic modifications. One legendary example was owned by Mizoda-san, the founder of Revolve SA. His 300ZX, purchased new in March 1990, was continuously developed over decades and achieved a verified top speed of 205 miles per hour. The car produced over 680 horsepower and was built for sustained high-speed stability rather than outright peak power. It represented the Japanese tuning philosophy perfectly. Build something that can perform at maximum capacity for hours without failure. The VG30 family, particularly the VG30 DETT, represented the pinnacle of what could be achieved with forced induction V6 technology in the early 1990s. While it's often compared unfavorably to the RB26 DETT in internet debates, the reality is that the VG30 DETT was actually the more sophisticated of the two. It featured variable valve timing 5 years before the RB26 received iTech technology. Its carefully tuned intake manifold system and advanced twin-turbo setup showed a level of refinement that was impressive even by today's standards. The VG30 ultimately gave way to the VQ engine family in the mid-1990s. The VQ featured an aluminum block for weight savings, improved cylinder head design, and coil-on plug ignition instead of a distributor. The VQ35DE in the 350Z and the VQ37 VHR in the 370Z carried forward the torch of Nissan's performance V6 legacy, but they owed their existence to the lessons learned from the VG30. Today, clean VG30 DETT-powered 300ZXs are becoming increasingly valuable. While they haven't experienced the explosive price appreciation of Supras or Skyline GTRs, collectors and enthusiasts are beginning to recognize them as undervalued gems from the golden era of Japanese performance cars. The aftermarket still supports them, with companies like Injuku Racing, Andes Autosport, and specialty shops worldwide offering parts and upgrades. The Nissan VG30DE and VG30 DETT deserve far more recognition than they typically receive. The naturally aspirated VG30DE proved that a well-engineered V6 with variable valve timing could deliver smooth power and impressive performance. The twin-turbocharged VG30 DETT showed that Japanese engineering could create something that combined supercar performance with daily driver reliability. These engines dominated American road racing, set speed records, powered one of the most technologically advanced sports cars of the 1990s, and proved their worth on streets around the world. They were sophisticated, powerful, and built to last. The VG30 DETT in particular represented the final evolution of Nissan's belt-driven DOHC turbocharged engines, following in the footsteps of the CA18 DET and RB20 DET, but surpassing them in refinement and capability. In an era defined by legendary engines, the VG30 stood tall. It may not have achieved the same fame as some of its contemporaries, but those who know. The VG30 was and remains an underrated giant of the golden era, proving that sometimes the most overlooked engines are the ones that deserve the most respect.